Hello, Honors Calculus. Welcome to section 2.3. You made it. Congratulations. You made it through taking derivatives the hard way, which is through the limit definitions. There are shortcut rules because the math is so beautiful, so elegant. There are shortcut rules that allow you to do this very quickly. So congratulations and welcome to 2.3. What if I gave you a function like this? F of x equals x cubed plus sine of x minus the natural log of x. And I told you, please find f prime of x. Could you do it? Yeah, you could use a limit of a difference quotient, but look how heinous that would be. The limit as h approaches 0 of x plus h cubed plus sine of x plus h minus natural log of x plus h, all of that minus x cubed plus sine of x minus natural log of x all over h. You'll get an indeterminate form here, and then you'll have to do some math. And gosh, that'll be not fun. We don't want to do that. Now watch how fast this is if I use shortcut rules. I know the shortcut rules for all kinds of functions. I know the shortcut rules for a polynomial. That's easy. Instead of x cubed, I'm going to have 3x squared. I know the derivative of sine of x, the derivative of that's going to be cosine of x. I know the derivative of natural log of x, derivative of that's 1 over x. Boom, I'm done. See, I just had these shortcut rules memorized, and so will you shortly. So, exciting stuff, people. So here are some shortcut rules. The derivative of a constant equals 0. This shouldn't be a surprise. If you took the derivative of a constant linear function, what's the slope of a constant linear function? 0. The second rule, d dx of x to the n, is nx to the n minus 1. In other words, the derivative of a power function is a power function of 1 less degree. Do you remember when we took the derivative of a quartic? What was it? Cubic. Remember when we took the derivative of a quadratic? What was it? Linear. The third rule is very helpful. d dx of cf of x, where c is a constant, is c of d dx of f of x. In other words, you can pull a constant out in front of a derivative. Why? Because you can pull the constant out in front of a limit. That's just one of the basic limit laws. The next rule is a more advanced rule called the product rule. If I have a function that is a product of functions, like I have some function, we'll call it h of x. That's the product of f of x and g of x. Well then, if I d dx that product function, if I d dx f of x, g of x, I'll get f of x, g prime of x plus g of x, f prime of x. In other words, the first times the derivative of the second plus the second times the derivative of the first. A fifth and final rule in 2.3 is called the quotient rule. Again, if you have a function h of x, which is really the quotient of two functions, f of x over g of x, you've seen this before. If the f of x and g of x were polynomials, this would be called a rational function. If you take the derivative of a rational function, what do you get? You get this thing called the quotient rule. d dx of f of x over g of x equals g of x, f prime of x minus f of x, g prime of x over g of x squared. The way we say it is low d high minus high d low over low low. The bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Low d high minus high d low over low low. All right, folks, you got to memorize these 5 shortcut rules so you can have them on your fingertips. Okay, there's one more rule in this section. d dx of x equals 1, and that makes sense. If you take the derivative of a linear function, y equals x, that's just a linear function with a positive slope of 1, constant slope of 1. Yeah, then if you d dx x, you should get 1. Now let's look at some examples. First, if I take the derivative of the constant function 3, if I d dx 3, what do I get? 0. If I d dx 3x, what am I going to get? I'm going to get 3. What if I take d dx of x cubed? Power function. I'm going to get 3x squared. And if I take d dx of 5x cubed, well, that's the same as 5 times d dx of x cubed, which is the same as 5 times 3x squared, or 15x squared. So let's look at these. What would you expect the derivative of the constant linear function y equals 3 to be? 0, because its slope is 0. What would you expect the derivative of y equals 3x, the linear function y equals 3x, to be? 3, because its slope is 3. It has a constant slope of 3, right? And what type of function would you expect to be the derivative of a cubic polynomial? A quadratic polynomial. And so it is. And that's true of both 3 and 4. Let's look at a bigger example. If I'm given the function f of x equals 3 minus pi plus x minus 7x plus x to the fourth plus 3x to the fourth, can you find f prime of x? Sure. What kind of polynomial is f? It's a quartic polynomial, so when I take its derivative, what am I going to get? A cubic polynomial. So you just follow the rules and you kind of string them together in your mind. What's the derivative of 3? 0. What's the derivative of negative pi? 0. Pi is just a number. What's the derivative of x? 1. What's the derivative of negative 7x? Negative 7. What's the derivative of x to the fourth? 4x cubed. And what's the derivative of 3x to the fourth? Remember, 3 is a constant in the front, so it's going to be 12x to the third. Here's another long example. Given a function g of x equals 4x to the 7th minus 6x cubed plus x to the negative 2 plus e squared, what's g prime of x? All right, let's just take it one step at a time here. The derivative of 4x to the 7th. Multiply 7 times 4, what do you get? 28x, and subtract off 1 from the 7, what do you get? 6. That's the power rule. Minus, what am I going to do? 3 times 6 is 18, x to the second. Now look at this next guy. Same process here, right? You got plus x to the negative 2. You bring the negative 2 to the front, x, and then subtract off 1 from negative 2, you get negative 3. And then e squared, what is that? That's just a constant. Just some number, 2.7 something squared. So what's the derivative of any constant? 0. Example 7. Take a look at that function, y equals x squared minus 17 over 3x to the fourth plus x to the fifth. What type of function is that? It's a rational function, a quotient of polynomials. So if you want to take its derivative y prime, what rule do you need to use? The quotient rule. What was the quotient rule again? It's low d high minus high d low over low low. Low is the bottom function, 3x to the fourth plus x to the fifth. D high, the derivative of the top function, which is 2x minus 0, minus the top, which is x squared minus 17. Low d high minus high d low, the derivative of the bottom next, which is 12x to the third plus 5x to the fourth. All over low low, which is the bottom squared. Example 8, y equals 3x squared times 2x. Now, what we could do is just multiply this through and get 6x cubed and take the derivative of that. That would be easy. But we're trying to learn something called the product rule. And so let's practice the product rule. Product rule is first d second plus second d first. The first function is 3x squared. D second, the derivative of the second function is 2, plus the second function, which is 2x, times the derivative of the first, which is 6x. Let me say that again. It's first times the derivative of the second, plus the second times the derivative of the first. And why did I use the product rule? Because this y function is obviously a product of two functions, the product of 3x squared and 2x. You can also use these shortcut rules within problems with context, more interesting problems. For example, this one, number 9. Find the points on the curve y equals x to the fourth minus 6x squared plus 4, where the tangent line is horizontal. Let's make sure we know we're doing this problem. You know this thing here is a quartic polynomial, so it's probably going to look something like this, right? It's probably something like this. The question is, where is the tangent line horizontal? Or find the points where the tangent line is horizontal. Do you see where you would have horizontal tangent lines? Where would they be? Right here, and right here. Horizontal tangent lines are tangent lines that have slopes of 0. And you can tell the slope is 0 right here, and right here for this y function. All right, so how can we do this algebraically? How can we find the points on the curve where the tangent line is horizontal? Well, you want to find where the slope is 0, or the slope, how do you say that? The derivative is 0. So let's start by taking the derivative function. So we're going to get y prime. We'll do y prime in blue. That's fine. Y prime, okay, what's the derivative of x to the fourth? You bring the 4 to the front. You take 1 away from the fourth power to get 3. N x to the n minus 1. It's the power rule. Minus, okay, it's power rule again on 6x squared, but you've got that constant in front of it, c, which is just going to kind of be there, so multiply by it. You get 2 times 6, which is 12, x to the first power. And then what's the derivative of 4? 0. You don't have to write plus 0 if you don't want, but here we go. We got the derivative function. Notice it's a cubic polynomial. It's what we'd expect to find. Now, I want to find where this cubic polynomial y prime equals 0. So, do I know how to find the zeros of a cubic polynomial? Hopefully, you get 0 equals 4x cubed minus 12x, and then this thing should not be hard. That's the same as 0 times 4x times x squared minus 3. So 0 is going to equal 4x times x minus the square roots of 3 times x plus the square roots of 3. It's a difference of perfect cubes in that way. And therefore we get zeros at x equals negative square roots of 3, 0, and square roots of 3. These are the points in the curve where the tangent line is horizontal. Technically speaking, these are the independent values. If you wanted to find the actual points, the actual ordered pairs, we'd have negative square roots of 3, comma something, 0, comma something, and square roots of 3, comma something. How are we going to find out what the dependent values are? Just plug these independent values back into the original function, right, to get the ordered pairs. So you'll get negative 5 for negative square roots of 3, 4 for 0, and negative 5. You're like, how do you do that again? Plugged in 0 into this y function, and you clearly get out 4. Same thing happens if you plug in square roots of 3. You just did the math. All right, folks, that's that. Let's have one last problem for today. Problem 10. Maybe it's a deal where we're given a particle is moving along an x-axis so that its position function is given by let's see, x of t equals 3t cubed minus 7. And I ask you to find, let's say I ask you to find the acceleration of the particle at time t equals 3. Okay, could you do it? How would you approach this? Well, you're given a position function, so you need to take the derivative, x prime of t. Why would you take x prime of t? What does that give you? That gives the velocity function, right? Use the shortcut rules. What's the derivative of 3t cubed? 9t squared. What's the derivative of 7? 0. So that's your velocity function. We want to know about the acceleration, so how do we find the acceleration function? Just take x double prime of t, which is the same as a of t. Got some acceleration function, just take the derivative of velocity. What's the derivative of 9t squared? 18t to the first, or 18t. Hey, now that I have the acceleration, can I find the function? Can I find the acceleration of the particle at time t equals 3? Yeah, what do? I just plug 3 into the acceleration function. And what do I get? I get 18 times 3, which is 54. All right, folks, that's it for today.